This is a list of steps that you can take for finding the real zeros of a polynomial function, and ultimately this will lead you to factor the polynomial. Okay, so I'm just going to read through it and then we will start doing examples. Number 1, use the degree of the polynomial function to determine the maximum number of zeros. Number 2, use the rational zeros theorem to identify those rational numbers that potentially can be zeros. Number 3, graph the polynomial function using a graphing utility to find the best choice of potential rational zeros to test. That means you're going to look at the list you generated in step 2 and you're going to compare to the graph. If you can kind of match the graph up with one of the zeros on your list, that's the zero you're going to start with. In step 4, you're going to use synthetic division or the factor theorem to determine if the potential rational zero is a zero or x-intercept. If it is, use synthetic division to factor the polynomial function. Each time that a zero and thus a factor is found, repeat step 4 on the depressed equation. Depressed equation just means what's remaining. In attempting to find the zeros, remember to use, if possible, the factoring techniques that you already know. Okay, and that's a good point. Okay, we're going to be working with higher degree things, but remember, if along the way you end up with something quadratic, you might be able to factor that, without using any kind of advanced technique. You could even use the quadratic formula on it. Okay, so use the tools you already know. We're just going to add to our toolbox here. Okay, we'll be using some advanced techniques to do this as well. Okay, I know reading through these steps is a little tricky. It will definitely help to just start going through examples. So let's take a look at the next example.